All right, guys, let's get started. Hello and welcome to all that have decided to spend the next hour with us. My name is Kristen Davis. I'm the head of marketing over here at 42 Crunch, and I'm joined by my colleague, Isabel Mani, our CTO here at 42 Crunch. She will be doing all the heavy lifting today for this webinar. Thank you, Isabel. Today, our webinar is Positive Security for APIs, what it is and why you need it. So if that's what you're looking for, you're in the right place. Before we get started, just a few housekeeping items. I have everybody muted right now to avoid distractions. And if you're having any, you can't hear, there's technical problems, and you're able to do the chat, just let me know and I'll try to help you. Which brings me to my next item. Questions will be answered at the very end of the presentation. We'll get to as many as we can as time permits. And don't put the questions in the chat box, put them in the Q&A box. I'll look at the Q&A first before I go to chat. So if you want it to get answered live, then put it in the Q&A box. But don't worry, we're gonna make sure we get every single question answered in a follow-up blog. So if we don't get to it today on our webinar, I'll make sure that we have the blog posted for you. It will be emailed out and it'll also come along with the recording as well. All right, guys, that is it. I'm going to sit back, relax, pass it on over to Isabel. You can take it here from Isabel. It's all yours.
Okay. Hi, everybody. Good morning, good afternoon, wherever you are in the world. So I'm Isabel. I'm CTO. I'm one of the co-founders here at 42 Crunch. And we're going to spend the next 30 to 35 minutes to discuss positive security models for APIs. And we'll get started right away talking about, what other security models do we have? Well, the one you may know more is Blacklist or negative security model. So in that model, basically what we say, well, we have a lot of people coming our way. We're gonna let everybody come in unless you're on the blacklist. So basically anything we deem as suspicious is going to be blocked. So this is a model really which is threat-centric, where we have created those lists and descriptions of potential threats, and we're matching whatever we're receiving against those patterns. And if they match, basically we'll suspect that this is something we don't want, so we will block it. That's really what a negative model is. And we have to contrast that to a positive security model, where there we say, this is what we want to accept. We know the traffic that we are going to receive, so we're going to accept only what we know. And so that model, by default, you're denied access. You cannot get in unless you're on the VIP list, right? Let's put it this way. And we know exactly who you are, and therefore we're going to let you in. So this is more about trust than being based on threats, about the fact that we know who you are, we know the traffic, so we're going to let it in. So in general, why is a positive model kind of a better approach? It usually gives us a much stricter access control because we know exactly what we want to accept, and therefore anything we don't want, we're going to reject. That also limits one of the issues with blacklists, which is false positives, which basically are things that enter in the rejected category when really they should be accepted. And by creating blacklists in general, we have a lot of false positives that are being reported. We have to go through and then refine those rules to actually make it more precise and giving us less false positives. It's usually also more efficient, like CPU and system-wise, simply because the way to handle a blacklist is usually to create those huge regular expressions that are, pages long and really take a lot of cycles and energy to be executed and evaluated, versus a positive list where I have much smaller regular expressions, such as this field contains a credit card, so it's 16 digits. It's a very simple way to express that and validate it. So it's more efficient. And one thing which is extremely important is if you're in a blacklist model, basically as new threats come up, you have to keep up with those threats to constantly put together new blacklists to consider those threats. This is not something you have to do in a positive model because you're focusing on what you know, what you're going to accept, as opposed to what you're going to reject. So on the outbound, you're probably thinking now, so why would we ever do blacklists? You know, it seems like positive model is actually much more efficient and better to do. However, one of the key problems with a whitelist has been traditionally that keeping up with it is actually complicated. So a whitelist is only powerful if it actually describes very precisely the traffic that you are going to receive. So it means that you have to keep up not with the threats, but you have to keep up with your application and all the changes in your application, so you can very precisely describe in your whitelist what your application does and the traffic that you are going to let in inbound and outbound. So it usually takes a lot of efforts in the web application world to actually maintain and create those whitelists. It's usually several people dedicated full time to actually doing that. So traditionally, it's been really hard for for web application protection to actually create whitelists. It's been actually more efficient and easier to have efficient blacklists, okay? However, APIs are different because we're lucky in the API world. We have something called Open API. You may know this as Swagger as well, which is a de facto standard which is supported by all the different vendors that you see here on the right side of the screen, which allows me to very, very precisely describe what we call the API contract. That is, every single piece of information, inbound and outbound, that my API is going to expose and manipulate, okay? So I can very precisely say, this is the verb, this is the path, this is my query parameter, all the headers I'm actually going to receive, this is the data that's going to come in, this is the data that's going to come out, and the absolutely every fine detail, the format of that data. And it's very easy actually to create. So back to what my point from before, you know, okay, whitelist we just said is kind of hard to keep up with. While in the API world, we have a lot of tools around the Open API standard, which allow us actually to create an Open API file from the code and generate it automatically from the code. So as the code is changing, I can keep up and have always an up-to-date Open API definition for it. Or I can have specialized tools that are very optimized to help me create and maintain my Open API file. So as a developer, it's actually pretty easy for me, either from the code or for specialized tools, to actually create and maintain that definition. And one of the key advantages that we see as well is if Open API, definition is going to be used for security, it actually allows me to do security very early in the life cycle of the API. We'll come back to that. So our really goal is to say, well, using Open API, you can really create the ultimate whitelist, the one that will basically be very precise and describe extremely precisely all the information flowing in and out. Will always be up to date because it's in sync with the code or creating with your tools as developers. And there's even a bonus to all of that, which is that you get a much better documentation for your API for your consumers. So as a developer creating APIs, it's always very important to be able to share what your API is doing and how it can be consumed. Well, Open API definitely helps with that. That's the reason it was actually created. So you're going to basically, hit two birds with one stone here, which is that you get better documentation and at the same time will have better security. So how do you get better security? Well, this is really the core of what we do at 42Crunch, is how do we leverage Open API at 42Crunch, right? So think of it, for us, this is really the core of our technology and our platform. And all our services really revolve around Open API. And the first step, basically, the core step of working with the platform is doing what we call an audit of your OpenAPI contract. As I said, the key point of a whitelist is that it needs to be complete to actually be efficient. So how do you ensure it is actually complete and has all the information that we need? Well, that's exactly what the audit service is doing. It's going to take your existing OpenAPI file, it's going to analyze it, and it's going to look at it from a security standpoint, from a data definition standpoint. And it's going to tell you, well, listen, you know, your OpenAPI file is missing all the security part, or you're using basic authentication, or really what the most secure way of doing this should be auth with that specific grant type. You're using HTTP, don't do that, you should do HTTPS. You're missing some definitions, the data is not properly, and we're going to give you a score, right? And basically the idea is you're going to refine your OpenAPI file until you actually get a good score. So that's kind of a, you know, think of it as a static analysis of how well your OpenAPI file is defined and written. And from there, once you get a good score, a good definition of that, then we're going to say, okay, now you told me what your API is actually doing, it's supposed to be doing. Now we're going to validate that against the actual implementation of your API. So we'll take the contract, we'll actually invoke your API based on that contract, and we'll see if actually the implementation conforms to the contract. So when you're telling me if something is wrong, I'm supposed to answer a 403 or a 405. Do you actually do that? And if you do it, do you do it with the data you told me you will actually send me back? How is your API behaving if I'm sending some information to it, which is not the one that you specify in the contract? So if in the contract you tell me your register operation takes a string, and that string is an email, if I'm sending something which is not an email, what happens? Do you actually catch that? You sending me a wrong proper response code for it, or you send me a wrong information? So we're going to basically make sure that the contract you're giving us aligns with the implementation. And usually we find a lot of issues out of that, okay? And then, you know, what you really want now that we found those problems is to protect yourself from this. So basically the runtime part of the architecture of the platform consumes that same OpenAPI file, the same one you've just audited or you just scanned and for conformance, and will automatically configure the runtime, the protection service. Think of it as a firewall for APIs from the same OpenAPI file, okay? So that's what we do. So now what I'm going to do is just take some examples of problems in APIs and see how the OpenAPI and a positive model help protecting against those, right? So I'm sure, you know, you probably saw, and if you haven't, I really encourage you to do so, to watch the previous webinar where we talked about the API security top 10 OWASP lists. And I'm going to concentrate on basically 4 of those related to data exposure and mass assignment. We'll get into details on injection. And if you want to know more about OpenAPI, about OWASP, just go and download this cheat sheet we have created, and you will have all the information on each of those different entries. So we'll start with you know, some of known problems and how we could actually address them. And I will start, you know, probably with the most famous problem, which is the Equifax attack. So Equifax, really the problem, the core of the problem of Equifax was the fact that they were using an Apache Struts version that actually had a vulnerability that actually stayed exploited for quite some time. Equifax, of course, because of the massive breach and problem, is what has been all over the news, but many different companies have actually been hit by that problem. And what is that problem? The problem basically is the ability to put in a content type header. So this is the script you see here in the middle of the screen. That's one of the attacks that they found basically when they did some analysis after that, is to be able to inject in the content type header that you see here a huge script basically. So this is a remote command injection attack, basically a remote command execution, where leveraging a vulnerability in the Apache Struts behind the scenes, this command that you see here on the screen is actually executed by the server. In this case, it's kind of a naive one because all it's going to say is who am I. So, but now if the answer of who am I is root, then the person who's done this has a lot of information. Say, okay, what else can I do? And what the things they've been doing after that, for example, is disabling the firewall on the systems where this was running. So that's the problem. So what is the root of the problem here is we have a content type, which obviously is not a content type at all. It's something that has nothing to do with what we expect a content type to be. So how do we address that with OpenAPI? Well, in OpenAPI, I can declare something that says consume. So basically, what is the data that is going to be accepted inbound? So for example, says consume application XML, you quoted application JSON, then this is the only thing my API should accept as the value of the content type, right? And you can also declare the same way all the requests and actually all the response headers as well in the newest version, in version 3, to just describe very precisely all the different headers that your API is going to accept, right? So that's what you can do in OAS. And if you do that, how are we going to basically address that problem in all the different services? So first of all, at audit time, if you have not defined consumes, we will let you know. We'll say, hey, you know, you're not telling me what is the data, what is the format of the data which is going to come in. So you have to tell me that, right? And at scan time, so when we test the implementation, what we're going to do is we're going to try, if you said you consumes JSON, we're going to try to send you something that has nothing to do with that and see how your API is actually reacting. And at runtime, we're going to basically block. So, you know, too bad for Equifax, but at the time, this huge problem they had was all about testing that the content of that header was actually application XML or application JSON. That was it. They could have avoided all this problem by just validating the contents of that header, right? So at runtime, what we're going to do is just look at that value for consumes and enforce that the content type is really what you told us, right? We'll block any header basically that is not matching the description. So if there are other headers that you have put it in with some constraints, that will block those if they're not matching those constraints, right? Obviously, we'll block any data that doesn't match the content type. So if you tell us the content type is JSON and you send it XML, that is not going to do it, right? And finally, an important point as well is all blocking all non-declared verbs as well. So something we do also on the request, for example, on the post, just to ensure that you actually cannot inject some information you should not injecting at that time, right? So just by putting this one line that says consume in the OAS, we can actually do all those validation absolutely automatically. So that's one, you know, main problem around content type. By the way, this problem from Equifax also had some other headers that could be exploited, and it will apply exactly the same, like content length or content disposition. It will be the same problem. Other issue, a Harvard registry. So this is a pretty recent problem. Basically, this is a very common issue of something called mass assignment. So what mass assignment is about is being able to update information that you're not supposed to update. In this case, there is basically a structure that represents a user. It has a username, it has an email, a real name, password, comment, and has this thing called as admin role, okay? So when you work with the API, when you get the information about the user, you're gonna see that you have all this information available, username, etc. So this operation is supposed to be only available doing a get to get the information, right? And I'm not supposed to be able to do a post on my role. However, and this happens quite often, you have a lot of frameworks which allow you to, for example, point at the database and then generate a REST API out of it, or better said, a CRUD interface on top of it, which allows you to create, update, delete the data from that database through a REST interface, okay? And while maybe you only need the GET to actually expose some information to a client, the post, the deletes, and other verbs are still there using exactly the same content, so the same structure of data. So the main issue here is I'm able to do a post of all the information. Really, I should only be able to do a post of what I've put here on the screen in green, right? Of the username and the email and maybe the comment, but certainly not of the password this way probably, and certainly not of the admin role, okay? So what do we have to do here in terms of Open API? So basically what we have to do is we have to describe exactly all the data coming inside our API. And we have to describe it in a way that there is no doubt as to the formats and limits of this information. So if I take on the right side this ID, well, no, it's an integer, but also I have a minimum and I have a maximum, right? I have an email and it has a string and it has to be an email, etc. And then I have this is admin, which you hear in red. And one of the core issues here as well is we're using the same schema to retrieve the data and to update the data. And really, it should be two different things, right? I can retrieve some data and expose some information in read-only mode that exposes the fact I'm not an admin, because it's a Boolean. However, doing a post, I should not have this is admin in there. There should be no way that actually I have this in here, right? And I should not be able to add it manually either. So there is this thing very critical in schemas called additional properties, right? And you want to make sure that you disable and you put this to false. Because if you don't, it means that although your schema has a certain number of defined property, somebody can come in and inject something else like this is admin one. And you really want to disable that, right? You want to make sure that I cannot inject something else that is not what you have intended to do an update of the data, right? So make sure that you actually describe very precisely the information inbound and outbound. And now, what are we going to do to help you there? So basically, first of all, we're going to detect whether you have actually associated schemas to requests. That we see that all the time. Most people actually tend to say, well, I have a body in there, but that body is really not very well described, right? So you want to make sure you actually describe pretty well that information. Then we're going to analyze how well that data is defined. So you have those patterns, etc. So if somebody is trying to basically do an assignment with information that you're not expected, we can actually block it, right? And we're going to tag this usage of additional properties, because if you have this set to true and you allow people to actually put anything they want in that structure beyond what you have actually defined, that opens to all kinds of problems, okay? And then we're at scan time, we're going to test that. So if you have defined properly your schema, then if I'm trying to inject something else through additional property, it should fail, right? And then we also will try to inject data which is not in the right format. So if you told us, this is, email, as I was mentioning before, username is an email. What if I don't put an email in there? What if it's too short? What if it's too big? So we'll check how your API is actually reacting depending on the data that you inject to it, okay? And of course, at runtime, we're going to consume that schema and we're going to enforce anything it says. So we'll define this, enforce the schema definition, we'll enforce those additional properties restrictions, right? And we'll block those non-declared verbs that we're mentioning before, okay? And last but not least, we're talking about Uber. So what happened here, this is another kind of the counterpart of the problem we were talking about before, which is related to exposing too much information. So here, those two actually work kind of together. Usually you will exploit an A3, so you will exploit the fact that the API is exposing a lot of information to then try to use that to push and update information through the other vulnerability, which is that you're allowed to do a post with a lot of data that you should not be allowed to do. But in this case, this is really about account takeover. This is a bug bounty, so no problem happened here. But there's two data leakages here that have happened. The first one, basically, so through the API, you would call with a phone number. You just have to know the phone number of a driver. And through the API, the error message when you were calling to get information about the driver would actually return to you something which is supposed to be entirely internal, which is the UID of the driver. So good thing, a good point for Uber using UIDs and not guessable IDs to identify the drivers. That's all good, but actually this should not be in the message itself. So now that I have the UID of the driver, I can use that through other parts of the API to get all the information from a driver. And that's actually a huge, I didn't put it in there, but if you look at that problem on the internet, you will see that that second call was returning this massive information, like the entire account information with the driver, like 170 lines of JSON, basically. And inside that was something which should never be exposed either, which is the token that basically the driver is using to enter in their Uber account. So once I have that mobile token, I'm basically, impersonating the driver, and I can take over the account and do whatever I want, right? So there's two problems here. The first one is leaking that UID, but then of course, leaking that entire structure, which actually is probably not used by the UI. And that's a very common problem of returning a lot of information and counting on the client application to just clean up all that information on the UI, and not thinking that if I'm going straight to the API, I'm going to get access to all of that, okay? So basically, again, this is all about schemas and defining, in this case, responses, right? So we're usually pretty good in all the Open API files that we see going through our community tools. A lot of people are reporting that the actual requests are pretty okay in terms of definition, but we tend to forget completely about defining well the responses, simply because usually the responses are not so validated. But you have to, right? So you really have to make sure, you have to own those schemas again. You have to make sure for every single response that you actually create and describe, in this file, you have to have a valid schema, a valid definition of what this response is going to be. This is to avoid two things. We talked about data leakage. There's another part of it, which is exception leakage. So if your API does not answer and behave properly when wrong data is sent to it, make sure that if for a reason that API returns an exception, that exception is going to be stopped in their track and will never get to the actual client, because that gives a lot of information about the internals of the APIs, and we don't want that, right? So you really want for every single response to have, for 200, for 202, for the 400s, for the 500s, 429, whichever HTTP code you're going to return, you want to have, what is it? What is the data that I'm going to return, okay? And again, how do we address that problem? So how do we help you there? So I have to say that in most solutions, security solutions, it's very common, it's pretty normal to validate the request, but very few validate actually the response. So we put a lot of emphasis on that because a lot of problems come from that, right? So we'll actually let you know at audit time, hey, you basically on the verb, you have not defined such and such response. So a lot of people define 200 and then they forget about all the others. So you're probably missing, depending on the verb you're using, you're probably missing a 404 or 403 if you're using authentication, etc. So first we'll tell you that. Then we'll tell you if you have those, whether you have or don't have schemas associated to those responses. And again, same as for requests, how well you have defined those schemas. And again, are you using this additional property? So if you have the same problem coming back that you only want to send to outside what, you don't want to exfiltrate information you shouldn't be exfiltrating, okay? And at scan time, we're gonna also make sure that the responses that, when we send you bad data through the scan, the conformance scan, making sure all the responses that come back are actually well defined in the contract as well, and they match actually all the different HTTP codes, etc. Right? And again, at runtime, what we will do, well, everything, you know the story now, everything which is outside of the schema definition will actually be stopped, okay, and blocked. So we'll block the response that are not matching the produces value. So we talked about consumes before. Well, we have the same thing for responses. If the response is not in the MIME type I have defined in the OAS, then I will stop that. We'll stop anything not matching the schemas. We'll stop any response which is not declared. I have this with a customer very recently where they have from time to time this 429, so a conflict HTTP code, and we're blocking all of that because that was not in the contract. That's a good example. And of course, we'll enforce again the additional properties restrictions just to make sure that basically everything that flows back is actually what you have decided should actually flow back. Okay. So why a positive model with 42 Crunch, right? So the idea is we're going to use the Open API specification. We're going to leverage it, and we're going to build the ultimate whitelist at design time. So this is very important, right? For security to be efficient, we have to really start as early as possible in the life cycle of the API. And this is something that we not see happening so much right now, where we tend to develop our APIs, we do functional testing, and at the end of that cycle, we start thinking about security and whether we've done everything we had to do. And it's usually very late, and it's very, time pressure is here very, very strong. For both development and security teams to do a good job at protecting those APIs. So really what we want is we want to start the earlier possible. And we want to start thinking about security as early as possible in the lifecycle of the API, which is why we really push this at 42 Crunch that the developers are key actors of the security. And at design time, what they can do is right there within the IDE, they can do this analysis. So let me just switch here since we have a few minutes left. I'm just going to show you what it looks like, right? So if I'm doing this audit in our platform, right? This is the score 43 that I have. So this is the information that will be given to me by the audit, right? And this information, I have a score of 43 and basically security, data validation, etc. You can have exactly the same thing from our platform, from plugins into your favorite IDEs, starting with VS Code today, or in your CI/CD pipeline, right? So you can start working on building that whitelist as early as possible in the life cycle of your API. Okay. And the idea is you have like, probably you're going to find a lot of problems. That's what happens to us all the time. So you need a report that will give you some priorities, right? Because you have to pick your battles, basically. So that's what your report is going to help you with. Then the implementation part, again, you can start with your Open API file at design time and have only the interface, and you don't even have the implementation yet. But the ability to, let's say in your integration pipeline, to actually do that scan and make sure that the implementation is also in line with the definition is also going to help you catch those problems very early, right? So that model of doing positive security is going to help you as well very early act upon potential problems before they become those expensive issues way down the actual pipeline of development, like at pre-production and even production. Okay. And finally, what we also wanted to do was to leverage also this description, which is extremely powerful and precise at runtime, right? So once I have this definition that it really explains in very detail all my API is actually doing, I can take it and I can deploy it through our platform into an API firewall that I'm going to deploy in front of my existing APIs. That can be in Kubernetes, it could be as in a gateway mode, depends on the architecture of your applications, of course. But I have something that is directly configured from that file. So I have this smooth feedback loop, right? And because we've taken this positive approach and we're using the OAS as the configuration, I have this direct loop as well, a very short loop of changing something at development time where I'm adding a new whatever, a new parameter to one of my schemas, right? New properties, I'm sorry, to one of my schemas. I'm doing that, I'm describing it, I'm pushing it into my pipeline. I get straight away whether this has impacted the code or not, the score, I'm sorry, of the audit or not. Then that pipeline goes through and am I automatically deploying my new firewall from this definition straight away. No policies to write, nothing to say more than just this is what I'm going to accept or not, okay? So this is what I wanted to share with you today. So I want to give you some free time to ask some questions. Christine, do we have any?
Hey there, yes, we have a few questions. The first one is, you've talked about positive and negative security, but what about AI-driven security?
All right. So yes, that's a good question. So basically, yes, there are current solutions that allow you to do some AI-based analysis of your traffic, basically. And that's another model, but basically what they're looking at is behavior. So there's something we really haven't talked about, but positive and negative really deals with the data and the format of the data and all the contract of the API. Now, from an AI perspective, some solutions which are complementary really to what we do, they will look at changes of behavior in the API call. So say the typical use cases would be, I have this token that has been used for the past day from that specific application with that specific request, etc. And suddenly that same access token is used from a complete different place with a complete different pattern. Is that normal? Yes or no? Well, at least it's a change of behavior, so we should probably know about it. And we should raise that concern to the security teams. Same would happen if suddenly, there's actually a very good example of that with a recent problem with Instagram, where through a password reset API, you have huge number of password resets that are happening from dozens or hundreds of different IPs on a single operation. So somewhere in a monitoring system, there's a huge peak of requests on one specific API through dozens of IPs. That is highly suspicious. The data is all good. So, I mean, the requests are all perfectly valid. The data is all fine. The tokens are all fine. But the behavior is not normal. And this is where the place of AI and API security really is. So it's very complementary to what we do.
All right, thanks, Isabel. So the next one is it possible to include the scan in stoplight? And how do I include the scan in my CI/CD?
Okay. So can I include my scan in stoplight? Not at this point. We're working on plugins to different systems. Stoplight is one of the candidates, but it's not there yet. And from a CI/CD perspective, yes, we have some plugins in different pipelines like Azure DevOps, like GitHub Actions, Bamboo, Jenkins. So if you have a specific one you want to work with, please get in touch with us, and we can get talking about it.
Okay, the next one is, where is your firewall deployed and is it Kubernetes friendly?
So yes, so our firewall can be deployed in multiple places. So really, again, it depends on your architecture. So you can either deploy it as a sidecar to your API, so it will intercept anything before it actually hits your APIs. And that is true equally of north-south or east-west traffic. So traffic coming from clients or traffic intra microservices, basically. So we highly recommend to build, a zero trust architecture in which you don't trust anything around you, even if it's a microservices in the same application, so that you will definitely validate and every single piece of data coming in and out. Should it come from your next neighbor microservices or from an external call? So that's the Kubernetes deployment. We can also be deployed as a gateway, like a standard gateway, reverse proxy, I would say, either usually before your API gateway, because we're really a firewall. So think of us as really a firewall replacing your web application firewall, but for API traffic, right? Because the web application firewall are using this blacklist approach, which is much less efficient for API traffic. So usually what our customers do is just to put the API traffic through us, through our firewall, and keep the original web application traffic through their existing web application firewalls.
Great, thanks. So the next one up is, how exactly does the tool work? Does it do a code of the scan across millions of lines of code and identify the vulnerabilities? Question mark.
Okay. So no, it's not looking at the code, it is looking at your open API file. So it's looking at the interface. So we're not a static analysis of code. We're only looking at the description of the interface written with this open API standard, right? Which also makes it much more efficient, because static analysis of code, you have to interpret how the code is written. It usually also triggers a lot of false positives. It's a completely different type of analysis. What we do is really looking at all those descriptions and how well you have written the interface of your API. So we're not looking at the code itself.
Okay, so next one is, when you detect an incident, do you block that transaction or just report the incident for correction?
So it's an option. So it's a setting. You can either put us in listening mode. So in this case, we will report everything we see and publish it. And you can push that to your security system, monitoring system of preference, or we can work in blocking mode. So you choose, and you choose that API per API.
Okay, next one is, as a whitelist protection against mass injection, what would be an appropriate response? Fail API or process only whitelisted attributes?
Mm-hmm.
If API fails, would it help an attacker in setting up a sort of reconnaissance or DOS attack by trying injecting various parameters?
Okay, so basically, in what we'll do, right? If you have our firewall in place and configured with a good whitelist, okay. Yes, if somebody is injecting a request, obviously that's going to create some stress, but on us, in terms of having to reject all those requests which are actually invalid. All right, but this is something we've planned for. So the system is able to scale to thousands of requests per second on a single instance of the runtime. So even if somebody is actually doing that, we'll actually make sure that we can handle that load, and we'll actually make sure we don't overload the system behind it with, for example, too many logging too much logging information. So we will just keep it our level and just reject it in there, and of course send alerts so that this hacker can be identified and stopped by maybe some at IP level or at some other network level in front of us. I hope that answers the question.
Okay, next one. Do you parse through entire request and response body to detect vulnerability? If so, how much latency this validation would cause on a transaction? Yeah, it's a very common question. So yes, we do. We validate every single request and every single response. It is actually part of the IP of the platform to do this extremely fast. Kind of rejoins the previous question as well. The latency, if we reject at the request level, usually it's sub-millisecond, and in less than a millisecond, we can basically reject that request, usually 100, 200 microseconds. And if we do the entire request response flow, it's usually 1 or 2 milliseconds. Even with some large payloads. So we recently did a large performance test where we were not passing of 3 milliseconds with payloads between 5 and 20 Ks at something like 3,000, 4,000 transactions per second, again on a single node. So yeah, it was built to be extremely fast and have a very low latency. So you can really put it across all your transactions and make sure that's pretty much invisible. Okay, next question. You've talked about Swagger specs, but do you support RAML as well? So no, we don't. Simply because also we actually have MuleSoft customers are using RAML, and what they have done is they have either automatically converted through the MuleSoft tools from RAML to OpenAPI, or used external tools to actually do that and automate actually the translation from one format to the next. MuleSoft has been extremely active to support OpenAPI as well, so we actually support OpenAPI exclusively at this point. Okay, one more question here. Since 42 Crunch works by enforcing the API contract, how does it work in the absence of OAS? For example, undocumented or shadow APIs? Well, the answer is it doesn't. So we need to know what we're going to protect. We can help, however, discover shadow APIs, because if you put in place something which is based on a contract, even a minimal contract, right? And you make sure that every single piece of traffic goes through us, through that learning mode that I was, listening mode that I was mentioning before, you're going to discover a lot of calls that you didn't even probably know existed. So we cannot work without an OAS, but definitely we're going to help you discover, and app security in particular, discover all those shadow APIs that they didn't know about and have to be basically cataloged and documented to be accepted. So yeah, it helps in that sense, because we really shouldn't have any APIs in our enterprise that it goes uncatalogued and unseen. And in that sense, this is what we also help doing, making sure that they are actually visible and cataloged. All right. Well, that's going to wrap it up for the Q&A. There are a few that aren't answered because you joined as anonymous, and there's a few different anonymous people out there, and I have to string together. Some of you sent multiple and they got mixed up. Next time, just create a funny name so I can tell you guys apart. Something that'll give me a laugh for the day. So those questions, I'll figure out what pieces of the puzzle go where, make sure they're in the blog. You guys will get an email of that. And you'll also get an email of this recording. We're gonna have the next webinar, January 9th. And it's gonna be a full demo of just the product. Nothing else. We're just gonna show you the product, how it works, and all the fancy things you can do with it. Isabel, is there anything else you wanna add?
No, that was great questions. Thank you very much, everyone, for attending. And I'll see you in January to show you indeed, now that we hopefully whetted your appetite for what the platform can do, to show it to you really live working.
Happy birthday for the person whose birthday is January 9th. We look forward to seeing you that day too. All right, guys, thank you so much for joining. Can't wait to see you guys after the new year. Have a great holiday.
Thank you for your help, Kristen. Thank you, everybody, and happy holidays, everyone.
Bye.
Bye.